Example 4. The owner of a video store has determined that the cost C in dollars of operating the store is approximately given by C of x is equal to 2x squared minus 18x plus 510, where x is the number of videos rented daily. Find the lowest cost to the nearest dollar. All right, so what's going on here is we have a quadratic function, okay? It is C of x is equal to 2x squared minus 18x plus 510, okay? So to get started, let's go ahead and identify the A, the B, and the C and kind of sketch out the parabola, and then we'll talk about the variables, okay? So let's see here. We've got an A value. A is the number in front of x squared, that's 2. B is the number in front of x, that's negative 18. C is the constant, which is 510. The A value here is positive, so that means we have a parabola that opens upward here. And that is great because we want, if you read the last sentence here, we're trying to find the lowest cost, okay? So here, we're trying to find a minimum value, okay? And if you have an upward opening parabola, then that parabola is gonna have a minimum. So again, we're after the vertex here, okay? All right, let's go ahead and draw a rough sketch of the parabola, okay? It does not have to be perfect by any means, but we need to kind of understand what the variables represent. Okay, so I've got my x-axis, and then here I've got my y-axis. Okay, it is not necessary to put this parabola into the calculator. We just need a rough sketch. Okay, we know that this parabola is going to open upward, so I'm just going to draw something that looks like this. Okay, we are after the vertex. This is the low point right here. Okay, so what's going on here is we have this owner of a video store, and this is something very common in business, okay? When you own a business, you of course want to minimize the cost to you. There's cost to running your business. You have to pay for rent, you have to pay for employees, and so on, okay? Materials, whatever. So you always want to minimize your cost, maximize your profit. So in this particular example, we have a cost function. The cost function is parabolic. So all we have to do to find the minimum cost is look at the vertex, okay? So if you look at the function, there's the variable x, okay? So you basically plug in an x value, that's going to give you an output, the y value. So again, let's talk about what these things represent, okay? If you read through the question, we need to figure out what x represents, okay? So just scan through it, and here's where it talks about x. It says x is the number of videos rented daily. Okay, so let's go jot that down. X is the number of videos rented daily. Okay, so the way this function works is you are going to plug in the x value, which is the number of videos rented daily. You will get an output, y, or C of x. C of x represents the cost in dollars of operating the store, okay? So on the y-axis, the y value, which is C of x, that represents the cost, okay? And that's going to be measured in dollars, okay? So basically, you plug in an x value, which again is the number of videos rented daily. The output will be the cost of operating the store if that many videos are rented daily, okay? Think about it. It makes sense, okay? If you have a lot of business, if a lot of videos are rented daily and you have a booming business, you're going to need things like, you're probably going to need more employees, okay? But if you don't have very many videos being rented per day, then you don't need to hire as many people, and so your cost of operation may not be as much. So definitely the number of videos being rented impacts the cost to the owner, okay? So what we're trying to do is figure out the lowest cost, okay? The lowest cost to the nearest dollar, okay? Like I said, the question is usually in the last sentence or so. Okay, so let me go ahead and highlight that for you. Okay, it says find the lowest cost to the nearest dollar. Okay, so when you read this sentence, okay, this is one of these vertex problems. Okay, usually that's what happens if it's, example 1 was pretty complicated, so was example 2 to an extent. But if you look at examples 3 and 4, they're pretty straightforward. It's just strict application of the vertex formula. Okay, so the question becomes with these is, do I need to find the x coordinate or the y coordinate of the vertex to answer the question? Okay, because your vertex is an ordered pair. It has an x value and a y value. Okay, well, when we read this, we need to be finding the lowest cost, the minimum cost. Cost is the y value. Okay, so here we need to find the y coordinate of the vertex. Okay, how do we do that? Well, the first step is we have to find the x coordinate. When you're dealing with these quadratic functions and you're looking at the vertex, you have to calculate the x coordinate in order to find the y coordinate. Okay, so we are going to start by finding the x coordinate of the vertex. That's negative b over 2a. Okay, so if we plug everything in, because we've already identified the a, b, and c, remember the negative sign is part of the formula. So if you have negative b, that negative is already there, and then you plug in b, that's negative 18, over 2a, a is 2. Okay, so this is going to be positive 18 over 4. Okay, so if we look at this on the calculator here, okay, we're going to have 18 divided by 4. We're going to get 4.5. Okay, which is kind of a strange answer because remember, x is representing the number of videos rented daily. Okay, you get a decimal answer, so it's like, how can you rent 4.5 videos? You might want to think of it as an average, maybe. Okay, an average of 4.5 videos daily. Okay, that's what's going to minimize your cost. Okay, and remember, that's what I was saying earlier. This is not a lot of videos at all. Okay, if you're barely renting any videos out, you don't need to hire as many employees. You're going to have a low cost. Okay, maybe not a big profit, but you're definitely going to have a low cost. Okay, x represents videos. Okay, so 4.5 videos rented daily. Okay, again, this is not what the question is asking for, so this is not the final answer. We're after the lowest cost to the owner. Okay, so that's the y value. So now that we have the x value of the vertex, we need to plug this number 4.5 into the original function to get the cost value. Okay, so we got to plug into our yellow function. Okay, so we're going to get the y value, which is the cost when 4.5 videos are rented daily. Okay, that's going to be 2 times 4.5 squared. Let's see, minus 18 times 4.5 plus 510. I think that's what it looks like. Okay, yeah. Okay, so I just plugged 4.5 into the original function. Okay, so let's go do this on the calculator. We're going to get 2 times 4.5 squared minus 18 times 4.5 plus 510. Okay, this will yield the minimum cost to the vendor. Okay, so this is going to be 469.5. Okay, so remember, this is cost to the vendor. So let's put units on this. This is dollars and cents, $469.50. The question does ask us to round to the nearest dollar. So if you round this answer to the nearest dollar, this is $470. Okay, this is the lowest cost of operation. Okay, so here you go. This is the answer. Okay, so let me box that for you. If you look back at the picture, okay, this vertex has, as an ordered pair, it is 4.5, saying that the owner needs to rent out an average of 4.5 videos per day to achieve a minimum cost of $469.50, and that's a daily cost. So that's approximately $470. Okay, and that is how you do this particular problem. Okay, so remember, with these types of word problems, okay, they're pretty straightforward, okay. You need to really be looking at whether your parabola opens up or down. It needs to match whether you have a max or a min that you're trying to locate. And then you really need to pay attention to what the x variable represents and what the y variable represents, because you're usually only solving for one of the variables.